discussion of this idea of trig identities on, what was it, Monday? Remember how I said that we had that one problem where it was like a sine squared and it had a singular cosine and then going on from there? No, it was Monday. That's okay. What happens here is that we have these things called trigonometric identities. And depending upon each of the identities, you can use stuff. I don't want to say that it's algebraic proof, but it's kind of trigonometric proof. But it's not a proof in the sense that you guys did in geometry of your two columns, your statements and reasons and things like that. What this stuff is going to look like is a lot of direct substitution. And it's, I would say, 90% of the material that we're going to talk about today are things that you already know. For example, we all know that we have the three generic trig functions. We have our three generic trig functions, cosine, sine, and tangent. Again, the reason why I put cosine first because it's the x value, x comes before y, and so on, and so on, and so on. Now, we also know that each one of these guys has a reciprocal property. Okay? When you reciprocal something, you flip the fraction. You guys agree with me on that? Which means that if I say that 1 over cosine, then, that's reciprocal, correct? What does that have to equal? What's the reciprocal property of cosine? Secant. Okay. The reciprocal, if I take the reciprocal of sine, what's the reciprocal property of that? Cosecant. And then the reciprocal property of tangent is cotangent. You might have noticed halfway through writing these out, my x's kind of disappeared. None of these properties work unless they're automatically the same value of x, the same value of theta, the same number value. It is, by all means, okay to not write down x for these because it lessens the words. It looks less wordy then. Instead of saying 1 over cosine x equals secant x, 1 over sine x equals cosecant x, I can just say 1 over cosine is secant. Is that okay? I'm just shortening up the nomenclature. I'm just cleaning it some. All right? I'm taking away 25% of your workload. Look at it that way. Yeah, if you look at it math-wise, you're like, oh, yeah, cool. You're not impressed. Shut up. Okay. Now, we also know that tangent is equal to what over what? Tangent is y over x, but what is your y value in trig? Sine. So tangent is the same thing as sine over cosine. Which means cotangent is what over what? Cosine over sine. Now, after those were basically things that we all knew. We knew that tangent's y over x, and cotangent is x over y. We know that their x value is cosine, your y value is sine, and so on, and so on, and so on. What's going to be somewhat new here are going to be what are called the Pythagorean identities. And one of them we talked about, the sine squared plus cosine squared. The reason that works is if you place your unit circle. No, you don't have to draw this. We always called our unit circle had a radius of 1. Going this way was your x value, this way was your y value. It's where you got your ordered pair x, y. Cosine was your adjacent, sine was your vertical. So you're able to say then that by Pythagorean theorem, cosine squared plus sine squared would equal 1. Because 1 squared is 1. Okay. So you have this first one that's called a Pythagorean identity, which means that if I have this cosine plus sine, cosine squared plus sine squared equals 1, I could solve what's called a literal equation. Literal equation means just get a variable by itself. If I want to get cosine by itself, what do I have to move? Subtract the sine squared, which means I can say that cosine squared equals 1 minus sine squared. Same idea, if I want to get sine by itself or sine squared by itself, It would just be 1 minus cosine squared. But in all honesty, if you think about it, the only one you have to know is cosine squared plus sine squared is 1 because you can manipulate the equation after that. You okay with that? The other two are a little bit weirder. We have one that says tangent squared plus 1 is secant squared, and cotangent squared plus 1 is cosecant squared. And those they're not terrible. I guess the only way that I've always been able to remember it was that cotangent and cosecant go together because they still both start with C. It's the only way I can think of remembering that one. Tangent and secant, T and that, they're next to each other, I guess, in the alphabet. Which means that I can say that tangent squared. Oh, yeah. What are you whining about? I heard my name. I thought you were trying to make a joke. I thought it was funny. See, that's why somebody wrote on the back during first hour. I think Sawyer wrote that up. Get a sine over cosine during spring break. What's sine over cosine? I thought it was funny. That's why this is funny. Protect yourself from identity theft. These are identities? He's stealing. All right. Now this means we can do certain parts, certain things. I do a. I'm already laughing about this next one. This is good. Ready? Tangerine. Come on, that's funny. That's funny. Devin, wasn't that funny? Yes? I'm sad face. Okay. Devin laughed. Okay, I get it. It's kind of inappropriate in this day and age, but about 10 years ago when I found that picture, it was great. Here's what happens. If you have sine over tangent, I'll leave the B's in here for right now. One of the things that's going to happen as we go through to simplify these things out is you're going to have a lot of fractions. When you have fractions, that just means it's something divided by something, or something times reciprocal. What happens here a lot, we're going to split this into something like that. All I did is pull apart the fraction. 3/2 is 3 times 1/2. 19 pi over 4 is 19 pi divided by 4, or 19 pi times 1/4. Edward, I just got rid of them right now. Okay. So what is 1 over tangent? That's reciprocal, isn't it? 1 over tangent is equal to what? Cotangent. So that means this is the same thing as saying sine times cotangent. Well, cotangent can be rewritten in terms of sines and cosines. Cotangent is what over what? Okay, what's your adjacent? Cosine over sine. Okay, so that means that I can take this value and write it as sine times cosine over sine. Hey, look what happens. What is 1 over tangent? You're going to have to go, I'm telling you for the first couple of times on this, you're going to have to religiously look at your sheet. 1 over tangent is a reciprocal. 1 over tangent equals cotangent. Cotangent is cosine over sine. What we're doing here is we're using direct substitution over and over and over and over again. Okay? All we're using is it over and over again. That's where I get my answer to simplify out to be cosine. Sorry, I didn't mention. Okay. Cotangent times cosecant. Here is a top tip. Did I say cos? I'm sorry, did I say cosecant? I'm sorry. So cotangent times secant. Here is a top tip. Anytime that you see reciprocal properties, cotangent, secant, those guys are reciprocals. I want to rewrite them in terms of sines and cosines. Okay? Cotangent is what over what? Cosine over sine. Secant is what over what? 1 over cosine. What drops? Cosines. Is the sine wearing a flotation device? No, which means it is 1 over sine, which is otherwise known as cosecant. Think of this as a puzzle. You are trying to do as much substitution as you can so you get rid of fractions and stuff. Right? On the calendar, I had 2 PDF files, one of which is the textbook stuff. I wouldn't spend too much time going through a lot of the examples in the textbook on this because they do a lot of half angles and negative angles. I am not going to give you guys any half angle formulas, nor will I give you guys any of the negative angle formulas. You will not see them at all in Algebra 2. I do leave them for the pre-calc teachers. Womp, womp, womp. So don't worry about any of those that you see. You're only going to be dealing with the ones that I've already shown you. Your reciprocal properties and your Pythagorean, the 3 Pythagorean identities. Okay? So on this, the calendar, I have this sheet called Trig Identities. I think it says a whole bunch of other stuff. It says Trig Identity, Puzzles and Extra Test Practice PDF. Well, it's just a giant puzzle. So what I want to do here is go through a couple of these with you to show you some tricks of things that you can do. For example, if I have cosecant and tangent. Sorry, I didn't show it nicely. So I have cosecant, tangent. Both of those can easily be rewritten in terms of sines and cosines. Do you agree? Okay. So I want to rewrite them in terms of sines and cosines, which means cosecant turns into tangent is. See you, Devin. And what do you get? Correct. Very good. And you just secant destroyed that problem. That's the song. Seek and destroy. Run away, hide. Sometimes you have subtraction and or addition between. There is a top tip for this. Secant minus sine tangent. Again, rewrite everything in terms of sines and cosines. When you have mixtures, always rewrite in terms of sines and cosines, and that's generally a great first step. Secant is what over what? 1 over cosine, good. Sine, that's fine. And then tangent is 1 over what? Sine over cosine. I'm going to put this over 1 because this doesn't change anything. Do I have a common denominator there? Cosine. So I get cosine and the denominator, and the numerator becomes 1 minus sine squared. And lo and behold, I have a weird suspicion feeling that 1 minus sine squared equals something. It equals cosine squared. And your answer is? Cosine squared over cosine, think of it as x squared over x. X drops out, you're left with x. It's a giant puzzle.
Why can't you just say cosine?
What fun is that? You have to think your way through it. Why won't we get numbers with it? Because obviously we won't be able to do it tomorrow, but when we get back from break, there is a whole other portion of equations that have identities and reciprocal properties mixed in that we have to know how to rewrite. So we practice the rewrite first, and then we show how to do it. Once we get the rewrite down, it works out pretty quickly. Because then the rest of the equation, you know how to solve an equation. It's just how do you get to that part. It's not as complicated as you think. Nope, not yet. Define complicated. Okay. Secant squared minus cosine squared times the secant squared. What do you think you need to do first? Take a guess. Well, if I change it to cosine, if I change it to cosine, I get secant squared. Well, wait a second. Wait, before I do that, aren't these two reciprocals of one another? Aren't those reciprocal properties? What happens when you multiply reciprocals together? It goes 1. What's secant squared minus 1? The identity says tangent squared plus 1 is secant squared, which means you can manipulate that and get tangent squared by itself. Now, if you pulled out a secant squared and factored it out, you would have wound up with secant squared times the quantity 1 minus cosine squared. Well, the 1 minus cosine squared would have been sine squared. You would wind up with sine squared over a cosine squared, which still winds up being tangent squared. There are you. Oh, you know, it's like the second problem. They're all like, what a nice brother. Come take you home. Good to see you. Yeah, good luck with everything, all right? Thank you. I'll see you soon. You, whatever. What do you think you should try and do here? Okay. What do you think? It is. Okay, you're right. Now, guys, notice the numerator has one piece, the denominator has two, and it's together by multiplication. When that happens, your trick is to split it into two fractions because it's not been said what's sine over cosine. What's tangent times 1 over tangent? 1. The right first step. There are very subtle little things you will see as you go through these. Okay. Now, I don't want to overburden you upon all this stuff because tomorrow you have that opportunity to succeed, shall we say. If I'm not mistaken, there's what, 12 of them? I believe we just did 4, and the rest of them should not take more than about 3 steps. If you wind up taking more than 3 steps, stop, go to the next one. If you wind up taking more than 3 steps, stop, go to the next one. Don't overburden yourself on this one, but I do want you to try to look at them. I think of all of the 12 that are on there, the only one that takes a little bit longer is number 11. There's a couple of weird things that occur in that one, so don't worry about it. I did not put any of this stuff on there for tomorrow. I did not put any identity stuff on there. There's no sine squared to change to cosine, -1, and things like that. I just wanted to make sure that we had this little bit of background knowledge because when we get back from break, we got to hit the ground running with this stuff. Otherwise, we're going to run out of time, and I won't be able to show you guys how to do probability, and then we won't be able to play cards, and we won't be able to play blackjack, and I won't be able to take your lunch money. I'm kidding. I don't take your lunch money. Yeah, that's one reason. But some of you guys might start wagering. I think Karaszewski could be the one. I think you're going to be the one that gets into trouble with gambling this year. We had that a lot. Oh, what was her name now? I totally forgot. Drawing a blank. Soccer player. Oh. No. She graduated last year? 2 years ago. Was it Hannah? Might have been Hannah. She had red hair, right? Yeah, it was Hannah. What's her last name again? Yes! Totally forgot. Feel bad. So Hannah, when we were in here, we were talking about blackjack and all that kind of stuff. She got addicted to a blackjack game on her phone. We had to have an intervention. It was bad. She was gambling too much. Like that. I mean, if she would have had money, she would have just. We're thankful that she didn't have like a credit card because it was bad. So don't gamble. It's not good for you. Yeah, there you go. Yes, sir. I don't know. I do know, but I won't tell you. That way, if you weren't part of that 60%, you'd be like,